Alrighty guys, what we're starting out with on the notes is not any different than what we've been doing. It's just sort of a great sort of review over the chain rule, because I know we're just coming back from a weekend. Only this time we're adding on to it. Rather than just finding the derivative, they want you to take the point and find the slope at that point, the tangent slope at that point, and then write the equation. So it's the same stuff you've been doing, they're just incorporating all the pieces together. So my first step is I'm going to rewrite S at t so that it's all that stuff to the 1/2. And then we can perform the chain rule. So the derivative of S at t, take the 1/2, toss it to the front, times all this stuff. Your exponent was 1/2. Subtract 1, we now have negative 1/2. Times, now the chain rule says you have to do the derivative of the outer function times the derivative of the inner function. So the derivative of the inside is just 2t minus, or plus 6. We could probably simplify this a little bit. 1 over 2 is that guy over 1 times that guy over 1. But really, who gets to stay on the top? 2t plus 6 times 1. So we have 2t plus 6 on the top. And on the bottom, we've got 2, and then this guy goes to the bottom because that's a negative exponent, and it's all in a radical. Now this is kind of what I was talking about earlier on the board. You didn't actually have to simplify that. You could have just taken this 3 and plugged it in for t. I mean, that's what you're going to have to do anyway. It's the same amount of brain power probably either way most of the time. Not always. Sometimes it's faster to just stick the 3 in. Okay, so we're going to find out the derivative at 3. So we're searching for a slope. So we have 2 times 3 plus 6, and everywhere I see a t, I put in a 3. So on the top we have a 12. 2 times radical 9 and 18 minus 2 is 25, isn't it? 7 and 18, 25. So we wind up with 6/5. What you found was the slope. You already have a point. They want the equation. So y minus the y they give you equals the slope we figured out times x minus the x they give you. And that's it. Questions on that one? Something like that, I could see me putting that on a test or a quiz, which is Thursday. I mean, that's not too rough. That's something everybody can do.
Yeah.
Moving down. Find the derivative. Alrighty, let's rewrite this. Whoops, not derivative, sorry. Equals x to the 1/2 plus 1/4 times sine of. Now, I could write 2x the quantity squared. I think it's actually going to be more brain power to do that because it makes a whole nother link in the chain for the chain rule. Can't I also just make that 4x squared? That's what 2x squared is. It's 4x squared. So this will simplify it by one sort of link in the chain for the chain rule. So then we find our derivative. Now we're adding two terms. The rule says you find the derivative of the first one and add it to the derivative of the second. So the derivative of the first is 1/2 x to the negative 1/2 plus, now we have this constant here. We're not squaring the sign, we're squaring this, just the x. What do I do with that 1/4? You can just bring it down. Yeah, just leave it. Derivative of sine is cosine. Rewrite the inside part. And that whole thing is multiplied by the derivative of the inner function, which is going to be 8x. Does everybody see what just happened? We have, this is the outer function, That's the inner function. So derivative of outer function, derivative of inner function. We're multiplying them together. And then we simplify. So I have 1 over 2 radical x plus 8x over 4, that's 2x, times cosine of 4x squared. Oh, the product rule? You don't have to because it's just a constant times a function.
So whenever it's constant times a function like that, you can drop it down.
Mm-hmm. You can just bring down the constant anyway. Well, and here, pick something that's a little simpler. If I have this and I'm finding derivative, really, you're doing the product rule, you just don't really know it. Because what is the derivative of 3? 0. So that piece, that whole term is sort of missing. Do you know what I'm saying? So you really have 3, like first, times derivative of the second, which is 2x, plus the second times the derivative of the first, which is 6x. So you can just bring that constant down and find the derivative of the function. Because this whole piece goes away. Do you guys see that? That's why it works. So that's our answer on that one. Any other questions? Those were good ones. All right, last one. Find the derivative of f at theta. I'm going to rewrite this because some of you guys need to see it written like this. I have tangent of 5 theta and the whole thing is being squared. For some of you, that'll make a difference. So we find the derivative of the outer function, then the derivative of the inner function, and then the derivative of the innermost function. This is one of those peanut M&Ms or pretzel M&Ms. So we take 2, toss it to the front, and I have 2 times tangent of 5 theta. And that whole thing times the derivative of the inner function. What's the derivative of tangent? Secant squared. So secant squared 5 theta times the derivative of the innermost function, which is 5. So simplify, kind of rewrite what you can, and I've got 2 times 5 is 10, times tangent of 5 theta times secant squared 5 theta. And that's it. Probably should have put it around the whole thing. Everybody okay? Those of you guys that weren't at school on Friday, you've had an extra day to kind of turn your brain off. Is everybody okay? Okay. Backside. You've been doing this. It just looks different. Kind of check out the chart, kind of see what's happening here. You've got some x values across the top. And they found the derivative of f at -2, and it was 4. The derivative of f at -1 was 2/3. They found the slopes of the tangent lines of that function for you for f. We have to find all of these. And we can find them because they do give us kind of some rules down here, or some kind of, I don't know, descriptions that tell us what g of x is. To find the derivative of g of x, don't you just take the derivative of the first guy minus the derivative of the second guy? So we have derivative of f of x. What is the derivative of -2? Derivative of -2? 0. What's 4? The derivative? Oh, yeah. Nick's gotten ahead of me already, smarty pants. That's okay. So the derivative was 0, so we don't even really need to put that. The derivative of g of x is whatever the derivative of f of x is. So I'm just going to have you write it out a couple of times, and then we won't have to after that. Bless you, by the way. We're going to find the derivative of g at -2, because that's the first x we're given. Well, everywhere I see an x, I put a -2. Derivative of f at -2. Derivative of f at -2 is 4. So that's also the answer for g of x. So, if I were going to write this some more, because this is our notes, you wouldn't have to do this on an assignment necessarily, but derivative of g at -1. I go back to my rule. Everywhere I see an x, I put a -1. The derivative of f at -1, according to my chart, is 2/3. So for g of x, it's also 2/3. Think we can figure that, like finish that row? Sure. Questions? Okay, let's move on. H of x. H of x, they tell us, is 2 times the function. To find the derivative of h of x, according to your derivative rules, it says all you have to do is leave the constant and multiply it by the derivative of that function. So let's see here. Derivative of h at our first x, which is -2. Everywhere I see an x, I put a -2. So I have 2 times the derivative at -2. What's the derivative of f at -2? 4. So it's 8. Same thing, derivative of h at -1 is 2 times the derivative of f at -1, which is 2/3 according to the chart. So 2 times 2/3 is 4/3. Do we see a pattern? Can we continue? Yeah, can we just double everything? Bless you. So we have -2/3, -2, -4, -8. Questions so far? Okay, r of x is a little different. To find the derivative of r of x, we've got a function inside of a function. That's chain rule. So, for chain rule, the definition says we take the derivative of f at whatever's on the inside times the derivative of your inner function. What's the derivative of the inside? -3. So if I want the derivative of r at -2, everywhere I see an x, I put a -2. So I really need f at 4 times -3. Do we know what the derivative of f is at 4? It's off the chart. We don't know. So you get to put an x there.
It's -3.
Because that's a -3. Crap. Thank you. Nice catch. That's a 6. Well, do we know the derivative at 6? No, it's off the chart. It's way over here somewhere. We don't know, so we can still put an x. Sorry. Good catch, guys. All right, next one. Derivative of r at -1. I go back to my beginning rule, and everywhere I see an x, I put a -1. So the derivative of f at 3. Do we know what that is? According to the chart, the derivative at 3 is -4. So I have -4 times -3, which is 12. So that's the slope right there. Let's try for 0. Derivative of r at 0 is the derivative of, and we go back to our very first rule that we wrote down, and it's -3 times the x value. We multiply by -3. So the derivative of f at 0, do we know what that is? According to the chart, it is -1/3. So when you multiply those out, what do we get? 1. You guys do the next 3 for r by yourself. I don't put D and E? Does not exist. Do we know that it doesn't exist? No, we just know that according to our chart, we don't have enough information, so we just can't finish it. Does that make sense to everybody? All right, let's try S. S at x. We're finding the derivative of this guy, and again, we've got a function inside of a function. So the derivative of S at x is going to be the derivative of f at the function on the inside times the derivative of the inside. What is the derivative of the inside? 1. So we probably don't even have to write that. So if we want the derivative of s at negative 2, everywhere I see an x, I put a negative 2. So I need the derivative of f at 0, which is negative 1/3, according to the chart. S at negative 1. Everywhere I see an x, I put a negative 1. So I need the derivative of f at positive 1, which is negative 1. Are you going to have to show your steps for the rest, or do you think you got the pattern figured out? This is an example from page 138. It's number 107. You guys are going to do page number 108 on your own on your assignment today. Are there any questions about this chart? Sure. You just have to use your derivative rules. These type of problems, guys, this is what shows up on the AP test all the time. It's stuff that calculator's not going to help you. You have to understand it in order to do it. So you really do need to understand and focus on this problem for sure tonight. Yes, sir?
On the R, everyone, where it's negative 1, could you do that again?
So maybe I did it wrong. I don't know. So the derivative of r at negative 1, everywhere I see an x, I put a negative 1. Negative 3 times negative 1 is 3. Don't forget you have the inside chain, which is negative 3. F at positive 3, the derivative is negative 4 according to the chart. So negative 4 times negative 3 is 12.
Okay.
You good?
Yes.
Okay. Anybody else? Okay, last little bit. Same type of question, but instead of a chart, they give you a picture. And they want you to find the derivative of h at 1. Well, they give you a picture of f of x and g of x, and then they tell you what h of x is. It's a function in a function, f of g of x. So let's define it first. The derivative of h of x is going to be the derivative of the outer function times the derivative of the inner function. So now we find the derivative of h at 1, and everywhere I see an x, I put a 1. And then we just have to look at our picture to figure this out. So I've got the derivative of f at, g at 1. You look at the graph. Here's g. At 1, we're at the y values of 4. So I'm going to replace this piece with the 4. Then it says the derivative of f at 4. How in the world am I going to get that from the picture? Derivative is a fancy word for slope. So let's go to 4. Go to f of x right there. What is the slope? Negative 1. Rise over run. So we have negative 1 times the derivative, the slope, where g is 1. What's the slope right there? Negative 1/2. I heard it. So the derivative of h at 1, is positive 1/2. Anybody want to see that again? All right, let's try the next one. We're supposed to find s at 5. Let's define the derivative for s at x. They say that s at x is g of f of x. You have a function and a function again. So to find the derivative, we take the derivative of the outer function times the derivative of the inner function. They want to know what that derivative is when s is 5. So everywhere I see an x, I put a 5. F at 5. So I look at my graph, go to 5, go up to f at x, I'm at 6. They want the derivative when g is 6. So here's g of x, here's 6. What's that derivative?
Oh, wait, there is
There is none. How come?
like this. Okay.
It's a sharp corner. Remember how we talked about there are like 3 places where the limits don't exist? Sharp corner is one of them, so it doesn't exist. Or, I mean, we just say we don't know. Well, no, it doesn't exist. It's D and E. Because we can see it, but it doesn't exist. Everybody okay?
G of 6.
Yeah, this guy right here. There was a sharp corner right there. Alrighty, so let's see. Your assignment is on the board. It's page 137. Numbers 52 to 70 even. Number 78. 84. 90 to 98 even. 108 and 110. Alrighty. Let you guys get busy.